The Sun, the blazing heart of our solar system, has burned for 4.6 billion years, providing the light, warmth, and energy that make life possible. But what if, in a single instant, that stability collapsed? What if our Sun suddenly exploded? It sounds like science fiction, but understanding what would truly happen can reveal just how fragile and miraculous our place in the universe really is. In this episode of Curiosity Now, we explore the science behind a hypothetical solar explosion and whether humanity could ever survive such a cosmic catastrophe. The Sun is not a solid ball of fire. It's a gigantic sphere of superheated hydrogen and helium, a nuclear reactor 1.4 million kilometers across. At its core, temperatures reach over 15 million degrees Celsius, where hydrogen atoms fuse into helium, releasing energy that travels outward over hundreds of thousands of years before reaching the surface. This process, called nuclear fusion, balances two competing forces: the inward pull of gravity and the outward push of radiation. As long as this equilibrium continues, the Sun remains stable. But if that balance were ever disrupted, if gravity won, the Sun could collapse catastrophically. To understand what would happen, we first have to look at how stars actually die. Not all stars die the same way. Massive stars, those 8 times larger than our Sun, end their lives in spectacular explosions known as supernovae. When their nuclear fuel runs out, gravity crushes their cores until protons and electrons merge into neutrons. The outer layers collapse inward, rebound off the dense core, and blast outward with unimaginable power. For a brief moment, a single star can outshine an entire galaxy. However, our Sun is too small to go supernova. Its destiny is far quieter and much slower. Roughly 5 billion years from now, it will exhaust its hydrogen fuel, swell into a red giant, and eventually shed its outer layers, leaving behind a dense white dwarf, a stellar ember that will cool for eternity. So in reality, the Sun cannot explode. But what if physics were different? And somehow it did. Let's imagine the impossible. A sudden failure in the Sun's nuclear balance causing total gravitational collapse. In a fraction of a second, the core would compress into an ultra-dense state, heating to hundreds of billions of degrees. That energy would rebound outward as a shockwave, ejecting the Sun's outer layers into space at thousands of kilometers per second. From 150 million kilometers away, Earth would remain blissfully unaware for about 8 minutes. That's how long it takes sunlight to reach us. During those final minutes, the sky would appear normal. Birds would sing, waves would crash, and no one would realize that the last photons of sunlight were already on their way. Then, the shockwave would arrive. Invisible at first, carried by blinding radiation and high-energy particles. Temperatures on the day side of Earth would climb to tens of thousands of degrees. The atmosphere would ignite, the oceans would vaporize, and the crust would begin to melt. Within seconds, every trace of life would vanish. As the explosion expanded, Mercury and Venus would be completely obliterated. Earth would disintegrate under the pressure, leaving behind only fragments of molten rock and vaporized metal. Further out, Mars, Jupiter, and Saturn would be scorched by intense radiation and stripped of their atmospheres. The shockwave would eventually slow as it collided with interstellar gas, forming a glowing cloud of ionized material known as a supernova remnant. In time, that cloud would spread across light years of space, seeding the galaxy with the elements forged inside the Sun: carbon, oxygen, nitrogen, and iron. Ironically, the same explosion that ended our world could become the birthplace of new stars and planets, perhaps even new life. In a way, death in the cosmos always leads to rebirth. Could we survive such an event? Only if we weren't anywhere near it. Even Mars, 225 million kilometers away, would be vaporized in moments. To escape, humans would need to colonize planets orbiting other stars, many light years distant. At our current technology, the fastest spacecraft ever built, NASA's Parker Solar Probe, travels less than 0.1% the speed of light. At that rate, it would take over 4,000 years to reach even the nearest star system, Alpha Centauri. So unless humanity invents faster-than-light propulsion or finds a way to upload consciousness into machines traveling through interstellar space, survival after the sun's explosion remains impossible. Fortunately, scientists are confident this scenario will never occur. The sun's structure and mass simply do not allow for a supernova-style explosion. Instead, it will evolve predictably, giving life on Earth billions of years to adapt or move on. Here's what astronomers actually expect. In about 5 billion years, the sun will exhaust its core hydrogen. Fusion will slow, gravity will compress the core, and outer layers will expand. The sun will grow more than 200 times its current size, swallowing Mercury, Venus, and possibly Earth. Its color will shift from yellow to deep orange and red, glowing less intensely, but covering more sky than we can imagine. For a time, the outer layers will pulse in rhythmic waves, shedding material into space until only the white-hot core remains. That remnant, a white dwarf roughly the size of Earth but half the sun's mass, will slowly cool and fade over trillions of years, becoming a black dwarf, cold and invisible. By then, humanity, if it still exists, will have long left this system, orbiting other stars under other suns. So, could the sun explode tomorrow? No. Its peaceful burn is one of the most stable forces in the known universe. But asking, what if, reminds us how fragile our existence truly is, and how extraordinary it is that we're here at all, orbiting a star just stable enough to nurture life. When you look at a sunrise tomorrow morning, remember, you're seeing light that left the sun 8 minutes ago. A gift from 150 million kilometers away, traveling through space and time to touch your face. For now, the sun lives on, and so do we.